Here we have a problem on exponential equation. That is, we have to solve for x in this exponential equation. Okay, to do the first step in solving this exponential equation, I consider the quotient rule of exponents. That is, I divide two terms with the same base. So here in numerator, we have the base a. In denominator also, we have the same base a. Whenever I divide two terms with the same base, what I can do is, I can write the base once and I have to subtract the exponents, that is m negative n. Actually, this is called quotient rule in exponent. Okay, now I'm going to consider the quotient rule exponent now in reverse order. That is, I consider the stuff on the right side. Here we have base a, and at the exponent, two values are in subtraction. So whenever two values are in subtraction of the exponent, what we need to do is we have to take this base a separately for this m and n, and I have to divide them as we have on the left side. So the same thing I am going to do in our problem, because here at the exponent we have two quantities are in subtraction, x and negative 2. So if I use the quotient rule over here for this 4 to the power of x negative 2, I'll be getting 4 to the x power divided by 4 to the second power. Since the two values are in subtraction of the exponent, I am taking this base 4 for this x and 2 and divide them as I explained over here according to the quotient rule of exponent. On the right side, whatever value I'm getting, I'm just taking as it is 0.125. Okay, now 4 to the x power, the evaluation of 4 square is 16 equals to 0.125. Okay, now let me multiply both sides by 16. Okay, when I multiply both sides by 16, this 16 and 16 will cancel. I'm getting 4 to the x power equals to, when I multiply this 0.125 by 16, I'm just getting 2. Okay, now to solve for x in this exponential equation, I have to get the same base on both sides. Once I get the same base on both sides, I can equate the exponents and I can solve for x. So using the one-to-one property of exponential equation. So whenever we get the same base on both sides of an equation, we can equate the exponents. So here on the right side we have base 2, but on the left side we have base 4. But 4 is a power of 2, that is 4 can be written as 2 square. So by writing 4 as a power of 2, I'll be able to get the same base on both sides. So now we can write this 4 as 2 square. Since we have the exponent x for 4, the same exponent should be taken out here, equals to 2. Okay, now let's consider the power of a power rule in exponent, that is a to the mth power whole to the nth power. So here we have the base a and we have exponent m. For the complete stuff we have exponent n. So whenever we have two exponents like this, what we can do is we can multiply the two exponents m and n. So the same rule I'm going to apply over here, because here we have base 2 and exponent 2, and for the complete stuff we have the exponent x. So what we can do is we can multiply the two exponents. 2 to the power of 2 times x is 2x equals to 2. Okay, now we can consider the exponent 1 for this base, because for this base we don't have any exponent. Whenever there is no exponent, we have to assume there is exponent 1. So now I can use the one-to-one property of exponential equation. That is, whenever two terms are equal with the same base, what we can do is we can equate the exponents. Then I'm getting 2x equals to 1. Okay, now to solve for x, I have to divide both sides by 2. When I divide both sides by 2, this 2 will cancel. I'm getting x equals to 1 over 2. I have solved for x in the given exponential equation. The value of x is 1 over 2.